Hello everyone. So today I just wanted to go ahead and put together a quick video just going over some extra integer exponent problems that I wasn't able to get through in class. So I don't know how long exactly this is going to be, but what you can do is I've actually posted this document here that you see in the description, so you can actually go and take a look at all of the problems and even try them on your own. Then if you want, you can go ahead and actually watch through the video and follow along with each of the problems. If you're feeling comfortable on some of the problems, but you want to, watch an explanation of how to solve some of the problems, I've actually linked the timestamps for each of these problems in the description, so you can just skip directly to the problem that you want to be solved. So to start, let's look quickly at what it means to even solve these problems. So to solve each of them, we need to make sure that these 4 bullet points are satisfied. So we want to make sure that in the final expression there's no zero or negative exponents. Those aren't considered simplified. We also don't want any double exponents, so we don't want anything that looks like x to the a to the b. We want to use exponent rules to simplify that down. We also want to make sure there's no parentheses. Parentheses are kind of used to make more complex expressions, but when we simplify, we want to make sure that those end up going away. We also want to make sure that any variables like x, y, or whatever only appear once in the expression, namely if you're looking at bases. So here, if let's say I had something that looked like x squared times x cubed, this would not be simplified because there's an x here and an x here, and we're not going to count that as being simplified. But if we go ahead and use some exponent rules and combine that together, we would get x to the fifth. Okay, so keeping that in mind, we can go ahead and start tackling some of these problems here. So the first one here we have is x squared times y to the negative fourth. So if we look again at the rules, we want to make sure there's no zero or no negative exponent. So here we see that it does have a negative exponent, so we're going to have to do something about that. There aren't any double exponents, there's no parentheses, and x and y both only appear once. So really it looks like we only have to deal with this negative exponent. So whenever I see negative exponents, I'm always thinking about trying to flip them down or up from the denominator to the numerator, or from the numerator to the denominator, whichever one is applicable to the problem itself. So here, what I can do to start is just write this as a fraction by just putting everything over 1, because you can always do this. Anything is just equal to whatever that is divided by 1, right? X is equal to x over 1. And so I can use this property here to go ahead and put this into a fraction because it wasn't before. And now I can use the useful tool that says, okay, whenever you have a negative exponent on one side, you can just flip it to the other side and make the exponent positive. So here, I go ahead and flip this y to the negative fourth to the bottom, leave the x squared up on top, and I'm going to make that negative 4 positive. So it'll be positive 4, not negative 4. Then we look at this here. We look through all the rules. We see that none of the exponents are 0 or negative. There's no double exponents. There's nothing like x to the 2 to the 3 or something like that. There's nothing like that. There's no parentheses, and x and y both only appear once. So we've gone ahead and simplified the problem. For the next one here, we have x to the fourth times x. Now, one thing that you absolutely want to remember whenever you're dealing with these exponent problems is when you have a variable alone, it's always equal to just x to the first power. It's the same way that we can add 1 times, we can add a 1 times to anything and it doesn't change the value, or a divide by 1, like in this case, doesn't do anything. If we raise something to the power of 1, it doesn't change it. So we can go ahead and write this 1 here. And that, depending on your familiarity with these concepts, it might be easier to go ahead and add that 1, so that way when you start applying your exponent rules, you're keeping track of things a little bit better. So now, well, here we're not simplified because we have x appearing twice. So we need to make sure, we somehow need to combine these. And if you look over the exponent rules, you'll see that we have the product rule that says whenever you're taking the product of 2 powers of the same base, so here we have x here and x here, so that's the same base, which means we can go ahead and apply the product rule. And it just says, okay, well, this is equal to x to the power of the sum of the exponents, so 4 plus 1. And if we go ahead and just do that addition, 4 plus 1 is 5. And so we see this is just going to be equal to x to the fifth. This is also simplified. Again, no zero or negative exponents, no double exponents, no parentheses, and x only appears once, so we are in fact done. Now we have problem number 3. So here we have x to the 4th to the 7th. Here we see that there's a double exponent, so we have to simplify. And here it's just a very straightforward application of the power rule. Whenever you have something raised to a power and then all of that raised to another power, this is just going to be equal to the product to x to the power of the product of the powers. So it becomes x to the 4th to the 7th, and this changes to x to the 4 times 7. Then we can just multiply 4 and 7 together to get 28. And here we can see, according to those bullet points, that this is in the simplified form. Next, we have a division problem. So we have x to the 15th divided by x to the 5. Now, it is very tempting. You might be tempted to say, okay, well, 15 divided by 5 is 3, so this is going to be x to the 3rd, right? But this is incorrect. So you want to make sure that whenever you're dividing powers of some similar base, so here in this case powers of x, that you're not just going to divide the powers. That would be incorrect. And we can actually see that if we write out what it looks like. We have x, 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 x. We have 15 of these. If I go ahead and write those out, I'm just grouping them in 5 to make it easier to see. So on top we have this. We have x times x times x, and so on. And on the bottom we just have 5 of them. Right? Well, here, if I start canceling, right, I can cancel this x. I can cancel this x with this x, this x with this x, this x with this x, and so on. And then what I'm left with is 10 x's on top. Or if you just remember the quotient rule, it says that you take the top exponent and you subtract the bottom exponent. So that's something you definitely want to make sure you're not making a mistake on, is dividing the exponents. You do not want to do that. You want to make sure that you are, make sure I can go ahead and leave this there. Want to make sure that you are subtracting the exponents. So this is going to be equal to x to the 15 minus 5, which is just equal to x to the 10th. All right, so now with the next one, we have a very similar problem. It's just now in the denominator, it's negative 5. What we're going to do with this is, well, we can apply actually the same exact rule as over here, but we can also do it a different way. I'll go ahead and solve it both ways, and it really doesn't matter which method you use. As long as you use one of the two methods, you're going to get the right answer. Just use and remember whichever of the methods is easiest for you to remember. So using the quotient rule directly, we see that this is going to be equal to x to the 15 minus negative 5. You just take the top exponent and subtract the bottom exponent. Now, if you remember your rules of double negation, this is just equal to x to the 15 plus 5, right? Minus a negative is just a plus. And so then we can just go ahead and do this addition, and we get x to the 20th. Another way that you can do this, if you like applying the rules of flipping things from the top to the bottom or bottom to the top whenever you have a negative exponent, the first thing you might do here is flip this x to the minus 5 to the top and make that positive. So we would end up with x to the 15 times x to the negative 5. Or really, x to the 5th. And now it's just a straightforward application of the power rule. We just add the exponents together, and we see we get the exact same thing. And in reality, these two methods of doing it are basically the same. They're just thinking about how to solve it in a slightly different way. Either of them is totally valid. So now we have problem number 6 here. And if we look, so we see there is x, y, and z all only appear once, so that rule is satisfied. There's no double exponents, so there's no x to the 5th to the 7th or something like that. There are, let's see, yeah, there's no double exponents. There are no, oh yeah, there's no parentheses. But if you paid close attention, it's 0 or negative exponents. If we have 0 exponents, we want to get rid of those. Now, how do we do that? Well, Always keep in mind that anything to the power of 0 is 1. And one way that you can remember that is, well, whenever you're thinking about what x to the 5th means, it means you start with 1, and I'm going to multiply by x, and I'm going to keep multiplying by x until I have 5x's here, right? And this applies exactly to 0 powers. So y to the 0th power, what I'm going to do is I'm going to start with 1, and then I'm going to multiply by y, and I'm going to multiply by y until I have 0 y's. Oh, well, I already have 0 y's, right? So it's just 1. And so when we simplify this, we'll get x to the 5th times 1 times z cubed. But here, this times 1 doesn't add anything extra, right? 1 times anything is just the anything. So we can just go ahead and drop that one entirely, and we get x to the 5th times z to the 3rd. So this is just, make sure you keep in mind that anything to the 0th power is going to be 1. So now, for this problem, this is a little bit different. I don't think I covered something like this in class. So when you have a negative number in these parentheses here, depending on your familiarity with the subject, one way that you can think about it is thinking about negative x as negative 1 times x. Right, so we have, well, because these two are just going to be equal here. Well, this means that we can actually write this as negative 1 times x to the 4th. And now all of the rules, all of the exponent rules were written down using variables. Like, you would see something like x times y to the a as one of the rules. But x and y could be variables, but they actually could also just be numbers. You could know their value. And so in this case, we have exactly this situation matching up, right? We have the x here, the y here is negative 1, we just know it's negative 1, and the a is 4. And so we can actually just directly apply the power rule here. And we get that this is negative 1 to the 4th times x to the 4th. So now here, another thing about simplifying is you want to make sure that there's no like expressions using constants. If you have just a whole bunch of constants, a whole bunch of numbers, you should compute what that is. So what is negative 1 to the 4th? Well, let's actually think a little bit about what happens when you take the powers of negative 1. So if I, let's say, have x here, I'm going to write down what negative 1 to the x is right here. So if x is 0, well, anything to the 0th power is just 1. And anything to the first power, so negative 1 to the first power here, is just negative 1. Now what I can do is I can just take the last one and multiply by negative 1 every time, right? Because x to the 2 is just equal to x to the 1 times x to the 1, right? We can use the power rule, the product rule backwards. And so, well, I know what x to the 1 is, and so this is just going to be negative 1 times negative 1, which is 1. Now, if I take the third power of negative 1, I'm going to do 1 times negative 1, which is negative 1. And we can see here that if we continued this on, that it's just going to alternate back and forth. So it's going to go from negative 1 to 1. Negative 1 to the 4th power is 1. Negative 1 to the 5th power is negative 1. And 1, and negative 1, and so on. And it just flips back and forth, back and forth, back and forth, forever like this. And you can notice here that whenever x is even, whenever this exponent here is even, the value of negative 1 to the x is 1. And whenever it's odd, it's negative 1. And that's a rule that you can remember. So negative 1 to the even is always going to be 1, and negative 1 to the odd is going to be negative 1. This is a rule that you can think about, or if you have a calculator and you don't remember this rule, you can just plug it into the calculator. But it's a useful little rule to remember. And so here, we see that this is negative 1 to 4. 4 is an even number because it's 2 times 2. And so we get that this is just going to be equal to 1, and we get x to the 4th. So now, for problem number 8, it's very similar to 7, except now we don't have parentheses, right? And whenever you read this, it's important to read it as this. If things are meant to be grouped together and a power applies to a group of things, there's going to be parentheses there, right? xy to the 3rd is not the same thing as xy to the third. Because this is saying, okay, I'm going to take 1x and then 3 y's. And this is saying I'm going to take xy, xy, xy. These two are different things. So it's very, very important to remember that an exponent is only going to apply to the thing that it's right above. It's not going to apply to any other variables that are multiplied by it unless those variables are grouped together in a parentheses, like in this case here. So in this case, we actually don't even have anything to do. There's no way for us to simplify, and we are done. But it's worth noting that negative x to the fourth is not equal to negative x to the fourth. So, right, because this one is just x to the fourth, and this one is negative x to the fourth. So it's something that you need to pay attention to whenever you're working on these problems, is not to mess up how things are grouped together. So for problem 9 here, it's very similar to this last one. We can actually just go ahead and apply the same idea, right? This is just going to be equal to negative 1 times x to the third. Then we can just use the power of a product rule to get negative 1 to the third times x to the third. And now, if we look at this rule up here, negative 1 to any odd number, like 3, is going to be negative 1. So this is going to be negative 1 times x to the third. And we can just write this out as negative x to the third. We don't need to write negative 1 times if we don't want. And here we have exactly the same thing as this negative x to the fourth. This is just equal straight up to negative x to the third. So actually, when the exponent is odd, the negative does kind of come out of the parentheses, right? You can kind of move it in and out freely. But when the exponent is even, you can't do that. You don't necessarily want to memorize that as a rule. You kind of just want to be a little bit more principled and remember the basic exponent rules. And eventually you'll get used to this idea. But this is not something that you just want to memorize off the bat. This is something that you should probably work out every time you see it until it really becomes drilled in your head. So now we're going to go ahead and move on to a little bit more complicated ones. These ones just covered the basic ideas again. And now we're going to move on to some that are just throwing a lot of stuff at you to make sure that you can differentiate them and process all of the information you have. So now here we have a negative sign. We have a fraction. We have just a number this time. And again, a number is going to act the same as any other variable. With regards to the rules, applying the exponent rules. So here, the first thing that I would do is I would go ahead and distribute this 3 inside of the parentheses because I don't really want to see it. I don't really want to have to do stuff in the middle here and then deal with the exponent on the outside. But it's also valid. You can start simplifying things in the middle and then simplify the exponent on the outside. But in this case, there actually isn't really anything to simplify in the parentheses. And so there's nothing for us to do inside. We can go ahead and just distribute this exponent. So to do this, I'm actually going to rewrite this negative here. I'm going to bring it up and group it with the negative 3. And that's just going to make dealing with this a little bit easier. So we have to the third power. So now we can use the quotient rule to go ahead and distribute. So this exponent 3 is going to distribute to every individual term, and it's going to raise all of the terms inside of a parentheses to that power. So we'll get negative 3 to the third over x squared to the third. So that 3 is going to come up here. It's going to come down here. And we'll see more examples of this happening later on. So now, well, what is negative 3 to the third power? Well, this you could probably just use a calculator for if you wanted to. Or you could remember this rule here. This rule, or this problem down here, right? We can see that negative x to the third is equal to negative x to the third, right? We can move it out of the parentheses. Well, here, if I just plug in x equals 3, I'm going to get negative 3 cubed equals negative 3 cubed. And so this up here is just equal to negative 3 cubed over. Now here I can go ahead and apply another rule. So this is a power raised to another power, so we want to simplify this. And in this case, it is, again, a power of powers, so we use the power rule, which says that our this is going to be equal to the x to the product of these two exponents. So 2 times 3. Then I can go ahead and we'll calculate what 3 to the third power is. It happens to be 27. And x to the 2 times 3 is just x to the 6th. And this is our answer here. So now we can move along to problem number 12. So here, we don't have really anything to do on the inside here, but I'm going to rewrite it just so that I'm grouping things together in the right way. And here we do need to simplify because, again, we have a power, some stuff on the inside with powers raised to another power. So we want to simplify that. So this is just equal to negative 2 times x to the third times y squared, all raised to the power of 3. Then we can use the power of a product rule, or power of a quotient rule up in this case, and just distribute the 3 to each and every one of these terms. So we get negative 2 to the third times x to the third times y squared to the third. Then we can go ahead and just calculate what these are. So here, using the same idea here, we can pull this negative out, and we can get negative 2 to the third, or if you just actually plugged this into a calculator, you'd see it would be negative 8 times x to the third. Remember the power rule. That means we multiply the exponents. So this will be x to the power of 3 times 3 times, and then this will be y to the power of 2 times 3. Then we can just go ahead and simplify those values. This will be equal to negative 8 times x to the 9th times y to the 6th. Because 2 times 3 is 6, and 3 times 3 is 9. And that's how we would solve this one, right? We're now in a nice simplified form. So now we're dealing with a problem that just has a lot more terms, and it has terms in the numerator and terms in the denominator. So probably the most useful thing to do here is to break this fraction up into a product of fractions, each of which only deals with one of the variables. So what I'll see here is I'll first start with just any constants, any numbers that appear in the formula. I want to just go ahead and take them out. So here I see there's this 12, so I'll put that on top and a 3 on the bottom. And this will be multiplied by, okay, well now I'm going to take all of the x terms out. So here I have x to the 7th over x to the 3rd. And this is going to be multiplied by, well here I'm going to take all the y terms, so I have y on top and y on bottom. And then I have z cubed on top and z squared on bottom. And I can always do this. Anytime you have a fraction like this and you have a whole bunch of things getting multiplied together, it can be very, very helpful to just split it all up so that you have like terms together and then reduce those down and then combine them at the end. That's just going to make your life a lot easier. So the first simplification we can do is just 12 over 3. That's just going to be 4. X to the 7th over x to the 3rd, we can go ahead and use the quotient rule. That's going to be x to the 7 minus 3. Remember, whenever you're doing a quotient, you don't divide the exponents. You subtract the bottom one from the top one. Here we have y over y. Anything over itself is always just 1. So this is actually just 1. These y's actually just end up disappearing. Then we can apply the quotient rule again. We get z to the 3 minus 2. Just the top exponent minus the bottom exponent. Then we just simplify this even more. So 4 times 7 minus 3 is 4. So x to the 4th. This 1 we can just leave out because it's anything times 1 is just the anything. We don't have to worry about the times 1. And then this is just z to the 1st. Or if you'd like, you can just omit the 1. Generally, in the simplified form, you'll omit writing any 1 powers and just write the variable on its own like this. But we went ahead and simplified this. Even though it looks a bit complicated, once you break it down like this, it makes it a lot easier to handle. Okay, so the next one, very, very similar idea, just some different values. So go ahead and break it apart. So I have 3 over 6. Those are my constants. Then I'm going to look for all of my x terms. And so, and here I could do the y terms first and then the z terms. Really, it doesn't matter what order you do them in. as long as you're just making sure that you write out all of the terms and they all end up written out. So here I'll have my x terms, that is x to the 7 over x to the negative third, times y over y squared, times z to the negative 2 over z. So now we can go ahead and simplify each of these things in parentheses individually and not have to worry about how they interact, because they don't really interact. So 3 over 6, that's just going to be 1/2. X to the 7th over x to the negative third. Just like with this problem right here, there's two ways to think about that. You can just do the quotient rule directly, or you can think about flipping this x to the negative third to the top. Again, does not matter which of those two you do. I'm just going to go ahead and use the quotient rule because it's a little bit more direct to write out. So we have x to the 7 minus negative 3. Then here we have, again, remember, y on its own is always just y to the first. So here, if I write the 1 here, this will now tell me what the exponents are, and I can use the quotient rule yet again. So this will be y to the 1 minus 2. And then finally, I have z to the, again, that's an exponent of 1. So this is z to the negative 2 minus 1. Then we just simplify this out. So we have the 1/2 here, that stays, times, well, x to this, well, 7 minus negative 3 is the same thing as 7 plus 3. 7 plus 3 is 10. So that tells us that the exponent for x is 10. Then we have y to the 1 minus 2. 1 minus 2 is negative 1. So this is actually going to be y to the negative 1. Now, this means that this form right here is not going to be simplified, so we're going to have to do a little bit more simplification afterwards. But that's totally fine. We're just going to deal with getting rid of these fractions first, and then deal with how we write things out later. So then we have times z to the, well, negative 2 minus 1, that's going to be negative 3. So now we actually have two terms here that are negative. So let me write this out. Since I have this 1/2 here times this, if you have a fraction and you're multiplying by any variables, you can incorporate those variables into the fraction by putting them on top. They're always going to go on top. So here we'll have x to the 10th, y to the negative 1, z to the negative 3 over 2. That's another way to just write this here. And to go ahead and solve this one, well, now we can just use the simple rule of moving exponents with negative powers to the other side of the fraction and making those exponents positive. So here, this y to the negative 1, I'll go ahead and move down into the bottom. So this will be y to the 1, because that exponent will become positive when we put it on the bottom. And the same thing for the z to the negative third. It'll go from z to the negative third on top to z to the third on the bottom. And now one final little thing. Again, normally you do not want to include one exponents either. Those you will just leave out. So I would just write 2y z cubed. I'm not going to write through the first because that's sort of redundant. It doesn't actually add anything. So this is our answer here. Just to make this more clear, this is a 2. Okay. So this is the general idea. Whenever you have this large fraction with terms, x is on top and bottom, y is on top and bottom, z is on top and bottom, break it apart, apply quotient rule to reduce the fractions of variables, and then group things together. And then at the very end, if you need be, you can go ahead and move stuff back up to the top or the bottom. Okay, so now we have the similar type of problem, but now there's also an exponent on the very outside of this. So here in this problem here, because this exponent is positive, the first thing that I like to do is just distribute that variable. Just get rid of it. That, or you can go ahead and start simplifying the inside stuff using the same method as above. I'll go ahead and start by simplifying using this method here. It's going to be a little bit tedious to write out, though, because we're going to have this large parentheses with the squared on the outside. But I'll go ahead and break this apart and write it a bit smaller. So we have 8 over 4. That's the numbers. We'll break that apart into its own fraction. Times, well, we have x to the negative third over x squared times y squared over y cubed. Right, those are the two y terms here. And if I go ahead and write them out, we can see that there's there, and here, and here. And finally, we have the z terms here and here. It can also be helpful maybe to cross stuff out as you write them down over here. That way you're making sure that you're not missing anything. Because if you miss anything, then your answer is just going to be wrong. So you want to make sure you're not missing anything when you write it out like this. So here I've done this sort of breakdown of the stuff in the middle, but I still have this squared on the outside. And I'm going to deal with that at the very, very end once I've simplified this down here. So this is going to be equal to, well, we can go ahead and simplify each of the terms. So 8 divided by 4, that's just going to be 2. X to the negative third over x squared. Well, that's, again, just quotient rule. So x to the negative third minus 2. Then we have y squared over y to the third. That'll be y to the 2 minus 3. And then z cubed minus z to the negative 2. So that'll be z to the 3 minus negative 2. And all of this is still getting squared. So now we can go ahead and simplify these powers here, write them a little bit nicer. So we have 2 times x to the negative 5 times y to the negative 1. 2 minus 3 is negative 1. Negative 3 minus negative 2 is negative 5. And 3 minus negative 2, well, that's just 3 plus 2. So this will be z to the 5th. All of this is still getting squared. So now that I've gone ahead and just simplified things down a little bit, now I can go ahead and distribute the exponent. So keep in mind this 2 is going to get distributed as an exponent to every single one of the terms, including the 2, including the constant. Don't forget that. Right? This 2 doesn't magically just stay and come out of this parentheses. It has to get raised by this power of 2 as well. So this is going to be equal to 2 squared times x to the negative 5th squared times y to the negative 1 squared times z to the 5th squared. Then you can just apply the power rule directly to go ahead and multiply these together. I can also simplify this 2 squared. That's just going to be 4 times, well, here, again, whenever you have a power of something raised to another power, you just multiply the powers together. So we get x to the negative 5 times 2 times y to the negative 1 times 2 times z to the 5th times 2. Then we just go ahead and simplify these exponents here. We get 4 times x to the negative 10 times y to the negative 2 times z to the 10. And finally, we just want to make sure we're getting rid of these negative exponents by putting them into the denominator if they show up, and in this case they do. So here we'll leave the 4 and the z to the 10th in the numerator, because again, this is just equal to this over 1, which is kind of implicitly there. And we'll move this x to the 10th to the bottom and this y squared to the bottom as well. And this is our answer. Another way you can go ahead and do it is first distribute the 2 to every single one of these terms in the numerator and the denominator. This might be easier for you to do. Maybe simplifying in the middle first is easier to do. Whatever works for you. So, but I will go ahead and just walk through this other method. So if I go ahead and distribute the 2, I will get h squared times x to the negative 3rd squared times y squared times z cubed squared, all of this over 4 squared times x squared times y cubed squared times z to the negative 2 squared. And then I've gone ahead and gotten rid of this outside exponent, and I can actually just remove these parentheses altogether. So now we can go ahead and simplify these constants and go ahead and apply the power rule. So here we'll go ahead and get 8 squared is 64, then x to the negative 3 to the negative 2. We just multiply those exponents. So that'll be negative 3 times 2, which is negative 6, times y to the 2 times 2, which is 4, times z to the 3 times 2, which is 6. All of this over 4 squared is 16. times x to the 2 is x to the 2 plus 2, which is 4, times y to the 3 to the 2, which is y to the 3 times 2, which is y to the 6. And then we have z to the negative 2 to the 2, which is z to the negative 2 times 2, which is z to the negative 4. And then you would just go ahead and follow this process along the same as you would do this problem. So it's entirely your choice. You can go ahead and simplify in the middle first using this method here, then distribute the exponent once you've got it into a simpler form, and then do final manipulations to get it into the final form. Or you can go ahead and do this, then group things here. So if we go ahead and group things here, we'll get 64 over 16 times x to the negative 6 over x to the 4 times y to the 4th over y to the 6th times z to the 6th over z to the negative 4th. And we can see here, we can keep track if I go ahead and just cross stuff out. So we have the 64 here, the x to the negative 6 here, the y to the 4th here, z to the 6th here, 16 here, x to the 4th here, y to the 6th here, and z to the negative 4th here. And so now that I've crossed everything off and there's nothing extra here on either side, I know that I've done this translation from this form into this form correctly. Right? You want to make sure there's nothing extra and that you didn't leave anything out. Now we go ahead and simplify each of these individually. So we get, well, 64 over 16 is going to be 4. Then we can use quotient rule again. So this will be 6 to the negative 6 minus 4. So this will be actually x to the negative 6 minus 4, which is negative 10. So negative 6 minus 4 equals 10. Times y to the 4 minus 6, which is equal to negative 2. And then times x to the 6 minus negative 4, which is 6 plus 4, which is equal to 10. Oh, this would be a z here. And we can see actually that we got the same thing as over here. So when we go ahead and flip these two down into the denominator in order to write it out in its final form, we get the exact same thing. So it really does not matter. And this should be a positive 10 now because I flipped it down to the bottom. Y to the 2nd. And we can see it's exactly the same thing here and here. So it doesn't matter which one you do, but either one works. Either one will always work. So now with a negative exponent, I would recommend doing something first. So along with the rule that you can take negative exponents on top and put them onto the bottom, so like this here, or that you can take them from the bottom to the top. If you have a fraction here to a negative exponent, this is actually just equal to if you just flip the fraction and raise that just to the 8th power. So whenever you have a fraction raised to a negative power, this is a good thing that you can do right off the bat. It just helps to get rid of that negative and makes it so that you're not having to deal with it later. And it's also just a really easy step to write out, so you don't have to worry about it. And we can see that this is true because if we go ahead and distribute, right, if we go ahead and distribute this negative a to both the top and the bottom, well, now we have negative exponents, so we can just flip these over. So this is going to be equal to y to the a over x to the a. But now we can apply the power of a quotient rule backwards, right? We can just pull this exponent of a out from both the numerator and the denominator and write it like this, which is just what this is. And so this is a very, very nice rule, a very easy one to remember and a very easy one to apply. So that is the first one we're going to go ahead and do here. Flip the fraction and make that exponent positive instead. So here I'll just write this out as 10 x to the negative 3rd y z squared over 5x to the 7th y to the negative 3rd z, all to the power of negative 2. I'm only going to go ahead and do this, or sorry, all to the power of 2, because I went ahead and flipped the fraction. So I'm not going to solve this in the two different ways like this. I'm just going to go ahead and simplify it on the inside and then distribute the 2. So here, first thing I have is 10 over 5 That's just the numbers for grouping together. Then I'll go ahead and cross them out just to show what you might do while you're showing your work. Then I have the x's, so I'll go ahead and put x to the negative third up here, and x to the seventh, which appears on the bottom here. So that's this one and this one. Then I have the y over y. So that takes care of these two here. And then I finally have the z squared over z. And all of this, again, is still raised to this power of 2. We haven't gotten rid of that yet. So now we go ahead and, well, now we see that we've actually taken care of all of these. And so we can go ahead and move on to simplifying this down. So then we, again, go through each of these set of parentheses and simplify internally. So 10 over 5, that is just 2, times x to the negative third over x to the seventh. That we just take the top and we subtract the bottom. Negative 3 minus 7 is negative 10. So we'll go ahead and put x to the negative 10th. Then we have y over y. That's just going to be 1. Or if you like the quotient rule, this is just y to the 1 over y to the 1. So this result here is going to be y to the 1 minus 1, which is y to the 0, which is just 1. Keep in mind, anything to the power of 0 is 1. So however you choose to memorize that this is equal to 1 is totally fine. Just make sure that you know it. Then we have z to the 2 over z to the 1. Again, we can just add that 1 there for our own sake. And so applying the quotient rule, this is going to be equal to z to the 2 minus 1, which is just 1. So this will be z to the 1. And again, all of this being squared is still sticking around. That hasn't changed. So now we can go ahead and distribute this too, right? Everything's pretty much simplified here. I'm actually just going to ignore the fact that this times 1 is here because I don't really need it. 1 to the power of 2 is just going to be 1 because 1 times 1 times 1 times 1 times 1 is just going to be 1. Doesn't matter how many times you multiply it. So I can just leave it out there. Now I can go ahead and distribute the 2. And again, just to emphasize, this 2 is going to distribute to every single thing, every single term that is being multiplied together, including the 2. So this is going to be 2 squared times x to the negative 10 squared times z to the first squared. And then we can go ahead and we'll simplify the number here and use the power rule to simplify these. So this will be 4 times x to the negative 10 times 2. So that'll be x to the negative 20. And then z to the power of 1 to the power of 2 is going to be, well, here this is actually just equal to z squared, or you can think of it as z to the 1 times 2, which is going to be just 2. So this will be z squared. And then lastly, we see that we have this negative exponent here, so we'll go ahead and put that in the bottom and make that exponent positive. All right, second to last one. So here, if we went ahead and looked at, started going at it like this one here, we would start, breaking these apart here and then starting to solve them individually, simplify, and then distribute the exponent. But this is a case where maybe distributing the exponent first would be smarter, or at the very least, recognizing that this right here is just going to be 1. And how can you see that? Well, this exponent is 0. If I wrote this as one large variable, so this right here is just equal to whatever's in the box to the power of 0. And anything to the power of 0 is always going to be 1. And so it doesn't matter what's in here. It doesn't matter how complicated it is. It's just going to end up being 1 because we're raising it to the 0th power. So this is just straight up equal to 1. No work needed. It's just raised to the 0 power. And so it's just 1. All right, now one final one down here, just to work things out, kind of combining all of the things and even adding an extra variable to throw a wrench into things. So here, we'll just use the method of simplifying in the middle, then distributing the exponent. But first here, this exponent is negative, so I'll go ahead and flip the fraction and make this positive. So the first thing we'll get here is 3w squared x to the negative 1 y to the 4th z over w squared x to the 3rd y to the 7th z to the negative 1. And all of this raised to the 4th power. Okay, so now I can go ahead and start grouping things together. So this is going to be equal to, well, here I have a 3 on its own, so that'll just be its own thing. I won't have to simplify that. Then I'll group the y's together, or w's. So we have w squared on top here and w squared on bottom. Then I have the x's here, so that'll be x to the negative 1 over x to the negative 3. Then I have the y's, so I'll have y to the 4th over y to the 7th. And then lastly here I have z over z to the negative 1. And again, all of this 4th power here is still sticking around. It's worth noting, just briefly, that let's say this top one was rearranged so that it looked like this here. Y to the 4th, and then the denominator just stayed the same, for instance. Right. When I'm writing this out like this here, I would still write it in this form, right? I wouldn't just say, okay, I'm going to group these two together, and these two, and so on. That is not what I'm doing, right? I'm looking for all of the x's on top and putting them into this term. It's just that with all of these problems, all of the terms were already written in order so that it looks like we were just matching them up one at a time. But you really want to look. So for this, I have this 3 here. That's the first term. Then I have this w squared on bottom and this w squared on top. There's no more w's, so I'm going to group these together into this term. Then I have the x's, so I have this x to the negative 1 and this x to the negative 3, and I group those together to get this term, and so on. So the order of the terms might be nice. It might be in the order you end up writing them down, or they might be scrambled up, and you just need to make sure that you're looking at it properly. Otherwise, you're not going to get the right thing. So then, again, we just go ahead and simplify each of these separate things. So this 3 is just going to stay exactly how it is. That doesn't change. Then we have w squared over w squared. That is just equal to 1. So that's pretty simple. I don't even need to write parentheses there. Then I have x to the negative 1 over x to the 3. So here we can just use the quotient rule. So this will be x to the negative 1 minus 3. This will be y to the 4 minus 7. And this will be, again, this is just z to the 1, z to the 1 minus negative 1. And all of this is still being raised to the 4th. Then we go ahead and simplify this down. So this will give us, well, 3 is just going to stay. I can leave out this 1 because it doesn't matter. We have x to the negative 4, y to the negative 3. 4 minus 7 is negative 3. And then 1 minus negative 1, that's just 1 plus 1. So this will be z to the power of 2. Now that I've got this simplified down, I can go ahead and distribute the 4. Again, it also distributes to the 3. It distributes to every single one of the terms. So we get 3 to the 4th times x to the negative 4 to the 4th times y to the negative 3 to the 4th times z squared to the 4th. Distributes to everything. Then we go ahead and simplify and multiply things out. So 3 to the 4th is 81. Then x to the negative 4 to the 4th, we go ahead and use the power rule to multiply those exponents together and get that this is equal to x to the negative 16. Negative 4 times 4 is 16. Then here we multiply together. We have negative 3 times 4. That'll be negative 12. So this is times y to the negative 12. And then we have z squared to the 4th. So that'll be 2 times 4, which is 8. And so we get z to the 8th. And then finally, as the very last step, we go ahead and take these things with the negative exponents and put them in the bottom. And make that exponent positive. And that's all of the problems. If you have any further questions on any of these, feel free to go ahead and ask me. You can even ask down in the comments below. But yeah, hopefully this helped you out.